Hello and welcome. My name is Shannon Kemp and I'm the Executive Editor for Dataversity. We'd like to thank you for joining today's Dataversity webinars, Data Architecture Requirements, the latest installment in a monthly series called Data Ed Online with Dr. Peter Aiken, brought to you in partnership with Data Blueprint. Now let me give the floor to Stephen, the webinar organizer from Data Blueprint, to introduce today's speakers and webinar topic. Stephen, hello and welcome.
Hello and thank you. Hey everybody, welcome and thanks for joining us. We appreciate you finding the time in your busy schedules to join us for today's webinar, Data Architecture Requirements. As always, a big thank you goes out again to Shannon and Dataversity for hosting us. We'll get started in just a few moments after I let you know about some housekeeping items and introduce your presenters. Today we have a 1-hour presentation followed by 30 minutes of Q&A. We will try to answer as many questions as time allows, but feel free to submit questions as they come up throughout the session. I'll be keeping track. To answer the top 2 most commonly asked questions, yes, you will receive an email with links to download today's materials and the webinar recording so that you can view it afterwards. These materials should be sent out within the next 2 business days. And you can find us on Twitter, Facebook, and LinkedIn. We've set up the hashtag DataEd on Twitter, so if you're logged on, feel free to use it and submit your questions that way. I'll be keeping an eye on the Twitter feed. All right, now let me introduce your presenters. Peter Aiken is an internationally recognized data management thought leader. We seem to be off track a little. That's all right. We'll circle back. Many of you already know him or have seen him at conferences worldwide. He has more than 30 years of experience and has received many awards for his outstanding contributions to the profession. Peter is also the founding director of Data Blueprint. He's written dozens of articles and 8 books. The most recent is Monetizing Data Management. Peter is experienced with more than 500 data management practices in 20 countries and consistently named as a top data management expert. Some of the most important and largest organizations in the world have sought out his and Data Blueprint's expertise. Peter has spent multi-year immersions with groups as diverse as the U.S. Department of Defense, Deutsche Bank, Nokia, Wells Fargo, the Commonwealth of Virginia, and Walmart. He often appears at conferences and is constantly traveling. In fact, Peter, where are you at today?
Well, it's an interesting topic today. I'm in Dublin, California, but I'm going to interrupt you for a quick second, Stephen, and tell you the story of Dublin, because I was in Belfast, Northern Ireland one year, hinting desperately, trying to get to Dublin, because nobody has invited me there yet, in spite of the fact that I've been doing this for 30 years. And somebody finally put their hands up and said, Dr. Aiken, that would be Dublin, Ohio that you're trying to get invited to, because of course that's where the Dublin core is. If that's an inside joke for you, sorry about it, but we had to go ahead and do it. Anyway, Lewis was out there last month, and our other presenter today then is?
That would be my friend Brian Hogan. He's a data consultant with a background in software development in the healthcare industry. Brian is a certified data management professional and has experience working with large international clients across many business functions. Past projects of Brian's have included organizational data management assessments, data strategy development, reporting solutions, and many more. Brian holds a bachelor's degree in computer science from Virginia Commonwealth University. Brian, how you doing today, buddy?
Doing good, Stephen. Thank you.
All right, without further ado, I'm going to pass the floor over to you, Peter.
Thanks, Stephen, and we'll bring Brian into the last third or so of the program, although, like I said, we may go back and forth a little bit on this as well. Thanks, everybody, and start out with our sort of creed. We believe that data is the most powerful, underutilized, and poorly managed data asset. It is your sole, non-depletable, non-degrading, durable strategic asset. And the problem with it is that most people think of it as oil. You'll see this all over the web. Data is the new oil. 5 million Google hits when you do that phrase. The problem with thinking about it as oil is that it really doesn't get to the reuse piece that we'd like to have. So we like to think of it more as data as the new soil. You plant things in it and it will grow in the long run. Some people say data is the new bacon. Whatever you got to do to get it sold and get it to people's attention, that's just fine with us. Because we'd like to have people talking about it, because our mission collectively is to unlock business value by strengthening organizational data management capabilities, providing solutions that work for the organization where it is on its journey to data maturity, and building lasting partnerships between the business, IT, and the data management community. And today, this is a topic that ties it all together perfectly, data architecture requirements. What we're going to talk about today is looking, of course, we always start off with our nod to the DIMBOK piece, but we'll dive in pretty quickly and look at what is data and information architecture, why are they important, and what does it mean to leverage this? And leverage is an engineering concept, so it's really critical that you get that this is a piece that doesn't come out of most college and university programs, and that the only place that you can get this information is from this type of programming here provided by Dataversity. Then I'll turn it over to Brian, who's going to give us a case study for Indigo. And Brian will tell us what an NGO is as we dive into that. And of course, then we get to our favorite part of the program, the Q&A pieces as we go forward on that. So let's dive right in and let's get started on it. I always like to refer people back to this, and the idea is that most people, for some reason, remember Maslow's hierarchy of needs from their high school education. I'm not sure why, except that it does make sense. And the basics of Maslow were very simple. If your food, clothing, and shelter needs at the bottom of the pyramid are unmet, it's impossible to build on to get to safety, love, esteem, self-actualization. And it turns out data is an awful lot like that. We have these wonderful data management practices that people have been looking at. We call them advanced data management practices. But that really does represent just, of course, the tip of the iceberg, and that lacking these foundational data management practices underneath it, it's very, very difficult. Again, it's like missing food, clothing, and shelter and not being able to go home and do whatever your self-actualizing pieces are. The real key with all this, of course, is that these foundational practices also have to rise in unison. What I'm showing in this illustration is that the data platform, data architecture piece is the weak link in the chain here, and for whatever organization this is representing, this organization had better put time and attention and resources into improving their data management platform and architecture, because any additional effort into governance, quality, strategy, and operations is simply not going to produce, because the foundation is only as strong as the weakest link. The key piece to all of this is that the golden triangle of data management practices, MDM, data mining, big data analytics, all these things are fundamentally technologies, and there's nothing wrong with them. They work really well, but if the organization isn't ready for them, the organization is not going to be able to use them as well as the vendors would like them to be used. So our advice here collectively is to strengthen your capabilities, because if you get your capabilities up and running better, you will be able to get there faster, better, and cheaper. In fact, we actually say that, it doesn't matter if you need it by Friday. If you want to do it without doing the foundational practices, whatever you're doing is going to take longer, cost more, deliver less, and present greater risk to the organization than instead if you learn to crawl, walk, and run your way to the process. Be also very happy as well with the capability maturity process that CMMI has put out as of August 2014, which is, again, taking those foundational capabilities and saying that from a strategic perspective, we want to take our data management practices from the work group level, where they are currently practiced pretty well, and put them to a coherent level that supports organizational strategy. That there is a profession now associated with data management, and that we can look at them and determine objectively whether the data assets are being managed professionally or not, that the data can now be determined to be fit for purpose, that the architecture can be appropriate and the life cycle also can be appropriate, and that the organization has the requisite supporting processes in place. When you couple the DMM with the DIMBOK here, we now have a way forward of how to get better at this process. And if you notice on that chart, the very top of it, I highlighted in sort of orangish the data architecture management at 12 o'clock. This is the section of the DIMBOK that refers to this. And you can see we have inputs, processes, and outputs. This is generally a graphic representation of what we're going to talk through today. So let's get started. When we talk about architecture, one of the problems is that it's a word that means many things. In particular, it's both the process and the product of the planning, designing, and constructing functions for large, complex things, whatever they happen to be. The key to this is to understand that all organizations have architectures. It's kind of fun because we get a lot of questions at Data Blueprint where people will come to us and say, can you come build us a data architecture? And the answer is, you actually have one. All organizations have data architectures. The question is whether you understand them. And if they're not documented, nobody can understand them. And if they are not documented, therefore they cannot be understood, they most assuredly cannot be useful to the organizations. So these architectures are symbolic representations. They have common components. They use standard notations. And what we're trying to get to is literally to be on the same sheet of paper. Understanding an architecture is essentially documenting and articulating as a digital blueprint the commonalities, the interconnections, and the architectural components that we have in there in a format that is understandable by humans as well as by students. And I just ripped this next slide off the internet here, but it's a kind of a cute little illustration of organizational architectures. Again, Amazon has sort of a traditional structure with Jeff Bezos at the top. Google is run by the gang of three that they have. Facebook, well, your structures are different. Microsoft, again, the joke here is that they eliminate their own products. Apple, everything revolved around one individual, and Oracle buys one company after another. But you can see from these representations, it's actually kind of cute, but it's also kind of true. And so this is a way of understanding how these architectures work. Within an organization may choose to manage one or more of these architectures. A process architecture, a systems architecture, a business architecture, a security architecture, a technical architecture. I heard this term recently, architecture. Okay, we don't need more terms. And of course, finally, what we're going to focus on today, the data and information architecture. But warning sign, if your organization thinks that these technical committees that are doing this good architecture work is just a bunch of committee meetings where nothing useful is happening, you have a challenge. And our measurements show over the years that fewer than 10%, 1 in 10 organizations, actually manage these architectural components well in their organizations. So let's look at what is a data and information architecture here. And unfortunately, I don't like many of the definitions that are out there. This is a good one. My friend Jim O'Brien actually put this one out on his blog a couple of years ago, underlying information design principles upon which construction is based. Absolutely true and correct, but it's not something, because I want you to think of this in terms of an elevator speech where, you know, you get on the elevator at some point, and the top official of the organization that you work for walks on and looks down at your badge and says, so you work for me, tell me what an information architecture is. And if you say something like, well, they're the plans that guide the transformation of strategic organizational information needs into specific information systems projects, it's a true statement, but they're not necessarily going to understand that. A framework for providing the structured description of an information house. Again, you see why I have a problem with these. I want to call out this book, Information First, by Roger and Elaine Evenden. It's a fabulous book, and they did a great job on it. My quibble is, again, if you try in that elevator speech to say information architecture is a foundation discipline describing the theories, principles, guidelines, standards, conventions, and factors for managing information as a resource, producing drawings, charts, plans, documents, designs, blueprints, templates, helping make everyone efficient, effective, productive, and innovative in all types of use of information, it's correct. But golly, the elevator's already stopped at that point, and whoever's in there is getting out. Even our DIMBOK, I quibble a little bit with the definition, defining the data needs of the enterprise and designing the master blueprints to meet those needs. Okay, so Peter, you don't like any of those? What is your definition of it? Well, let's move into the next section, which actually gets to a real important piece of all of this. We like to speak to motivation. So a useful definition of data architecture is that it is a common vocabulary expressing integrated requirements, ensuring that data assets are stored, arranged, and managed in systems in support of strategy. Now, I don't want you to memorize that, but I do think that it is a really good definition, because when the boss looks over at you and says, so you're into data architecture, what is that? If you say, I'm developing a common vocabulary, I guarantee you that every chief executive in your organization has had challenges associated with problems, and the problems come down to, well, we couldn't get one system to talk to another. So defining an architecture in terms of common vocabulary is something they can relate to. A little more usefully, it's a structure of data-based, not data-based, data-based information assets in support of strategies. Again, I've already said this, most organizations have strategies. but they're not really supportive of architectures. If they're not understood, they can't be useful. So the question is, how can we help our organizations collectively use their information architectures to better support their strategies? I'll give you a quick example on all this. In an organization that is developing a database is a shared resource supporting, in this case, 3 different application programs, Program A, Program B, and Program C. And the database architect is going to control the vocabulary of data that is shared among A, B, and C. And that is a perfectly valid function, and they do a great job of it. The challenge happens when another IT project implements the green database that I'm showing in the lower right-hand corner. The green database, of course, has a vocabulary that may or may not be the same thing. In fact, it is likely to be different unless we take some extraordinary action. And extraordinary just means extra. So the orange and the green and the brown databases could be done by 3 different projects, but our measurements show that much of the data in these databases is in fact shared, and that we should really be taking a broader focus on all of these, broader than software, broader than database architecture, and look at system-wide use of data in the organization, and ideally organization-wide use of the data. Because the problems that we face in organizations and in IT in particular are generally caused by data exchange or interface problems. And that these architectural goals then are much more strategic than operational in focus. This is, again, not taught in college and universities, and so it's a big problem. Again, it's also not terribly well explained in many cases. And it's only indirectly experienced, and that's where it really gets problematic, because people don't know that it's sort of death by a number of different experiences. I'll give you an example here on this now, specifically looking at poorly thought out software purchases. So this is a piece of software that we were looking at in the Defense Department in the late 80s, early 90s. I forget exactly when it was we were doing this, and we had to put a new personnel system in for the Defense Department. And I'm going to call your attention to a business rule that I'm highlighting on the screen here now. The business rule is 0, 1, or more employees can be associated with 1 person. Now, it's a correct business rule, but it's not terribly articulate in the sense that if somebody's trying to figure out what are we supporting here, it's not real easy to see. Now, it turns out that this concept, 1 person can be 0 employees, 1 person can be 1 employee, 1 person can be many employees, is a concept that's very useful in the U.S. Department of Defense, mainly because we haven't been paying our warfighters as much, perhaps, as we'd like to be able to pay them in return for their service to the country. And so many of these individuals take 2 jobs. They may work part-time for the Army and then full-time for the Navy. And the question comes up, do they count as 1, 2, or 1.5 people? And that's an issue that comes to counting, but when we're processing their tax information at the end of the year, if we don't recall that we have a person taking a job at the Army and the same person taking another job at the Navy, then we will misreport their tax information. And the process of simply remembering to pull all these W-2s together is a very big challenge for many organizations. The practice that I'm describing here is moonlighting. So somebody taking 1 job and working another job part-time, perhaps to fill their college tuition funds or something like that. Another example of the same thing here is that an employee can be associated with 1 position. 0 employees can be associated with a position, or multiple employees can be associated with a position. And of course, the concept here is job sharing. So once again, if we don't support these, if we don't look at these architectures from an architectural perspective, when I go out to buy a software package, I don't necessarily implement the best fit for the organization from the data management perspective. Let me be very specific on this. Your organizational purchasing function within IT or within the organizational purchasing should require every vendor that is giving you some software to lay out a logical data model for you. About half of the vendors will do this and say, oh, sure, there's a smart customer, we'll be glad to have them there. On the other hand, many of them don't, and that's actually kind of okay too. You can sort of keep them from being entering in the pool. We'll call it a self-selection process. So a vendor that gives you this is looking to see if their software will support the business practices of the organization. Let me give you another couple of examples around the same thing. Here's a query that we were looking at one organization. It's, you can see, pretty complex, and by going through and doing a little bit of work, we can optimize the query, making it easier, but never, of course, easy in that. The problem is, if you've got a lot of those running in your organization, hundreds, thousands, tens of thousands, millions of times, what it means is that the wrong architecture can end up causing your organization death by 1,000 cuts. Or, let's ask another question, how does poor data architecture cost money? Well, if your systems were not explicitly designed to be integrated or otherwise work together, what is the likelihood that they will just happen to do so? Because they can't be helpful as long as their structure is unknown. And John Zachman has given us these numbers for many years. 20 to 40% of IT costs are spent migrating, converting, or improving data around the organization. So from a business perspective, the goal is to develop a shared understanding between the business and IT, that we get data exchanges that are highly automated and thus dependent on successful engineering, that we need to model the characteristics of change over the course of analysis. We want to incorporate motivation or purpose statements in modeling activities. We want to use modeling as opposed to not using modeling. We don't often care these days which form of modeling is used, although I know you can get into holy wars over that. And understand that these models are living documents and that they need to be searchable, and that it doesn't hurt to add color and objects to these. This is a lesson I learned early in the defense. I want to thank Karen Lopez in particular for this particular list. She did a great job of articulating it in here. Because the problem with architecture is that while people will look at this house very many times and say, oh my goodness, that's a terribly architected house. If your mission is to add a dish TV receiver to the roof, that absolutely can be done. But if you have this house, which has a clearly broken foundation, there's no point at all in putting anything else up in that house because it's going to fall down. And of course, management's understanding of all of this is very, very simplistic on all this. Now, models face down, look at detail, architecture looks up, gives us a higher level of abstraction and the ability to do integration that isn't possible when we're looking downward. In the past, we attempted to gain a perfect picture of the architecture. It produced a great model of what the organization looked like 5 years ago. The problem is, of course, we can't have that in today's environment. It's not timely, it's not feasible. So what we need to do is redirect our architectural focus on specific architectural components to allow us to come in and govern these by a framework which puts them to work more immediately. Again, if I gave this picture to the executive that wanted to see something on the elevator as an example of what architecture is, an engineering firm might get it, but most senior executives are not going to be able to do this. And you have some allies in your organization. Your web people understand an information architecture. So they're always creating diagrams like this that says an information architecture in the web context connects people to content that they're looking for. Well, that's done via the web. This, for example, picture here shows you that one area has much deeper menu structures than other areas do. You can assume that that's where the content is going to be. Or even a simplistic picture like this that shows how these things are all relatively organized for the user experience on this. See, data architectures are always going to be expressed as architectures made up of data structures. We start out with details, and the details are organized into larger components that end up being models, and the models are then organized into architectures. This next chart, I want to just, it's a little hard to get because I start at the top with the attributes, and they are more granular, and then work our way to the bottom, which gets us to the actual architecture as well. On this, it probably should be flipped. I don't know. I haven't come up with a better way of representing it. Maybe that's where one of you guys on the call can actually help us by improving the presentation here. But again, this is the idea that we're looking granularly and abstractly, and we have to keep these things in mind as we're building large, complex objects. Now, another very important component here is to understand how data fits into the whole picture. I always use the number 42, which some of you remember is the meaning of life, the universe, and everything. That's a fact paired with a random meaning. Also, 42 is my age 15 years ago. So, you know, there's a random fact as well. Neither of these are helpful because we have to do more with it to turn it into information. And the only way that happens is that when we combine those fact and meaning pairs in response to a request. So you can see we are constructing something, we're building, we are architecting towards something. It turns out that just knowing the request isn't really enough, and we actually have to understand the strategic use of this. So oftentimes we use the word intelligence or wisdom or knowledge or data warehouse or something like this, which is the idea of how we're going to actually deliver all of this information as we go up and around. The real key to this is to understand, of course, that you can't develop an intelligence or even an information system without having your data architected correctly. And this is the real key to this. These are necessary but insufficient structures in order to do this. So next time somebody asks you how data structures support the organizational strategy, the answer to that is actually a good thing that I used to call my restaurant analogy. There's two answers for it. The first one is that we're going to achieve some goals in terms of effectiveness and efficiency. And the second one is that we're going to provide the organizational dexterity to be able to change rapidly when we are forced to change. Now, the restaurant analogy is simply this. If I have a restaurant that employs the top set of dishes up there, and they use a different dish literally for every different item on the menu. So in other words, if you're serving the customer a piece of corn on the cob, then you would have them make corn on the cob dish. And if you break the corn on the cob dish on the way to delivering the corn on the cob to the customer's table, then you have to go into the dish inventory and find the corn on the cob dishes before you can replace it. Whereas if you're in a different mode, maybe the goal there in the top one is elegance and presentation and setting. Hopefully some good food tasting as well in there. But if you're on the bottom part of it and you just say we're going to use the same plate for every dish, then we just grab the next plate off the stack. Those two architectures are critically important for the organization, in this case the restaurant, in terms of being able to deliver value. And notice that they support strategy in different ways. One of them is to become efficient, and the other is really looking at an innovation play. Now, data architectures address a lot of different questions, and it's important not to try to get them all at once. The real key here is to look at what problem you are facing and use an architectural representation in a manner that answers the question. Because if you try to be comprehensive about it, you will never, ever succeed. I already mentioned to you that it takes a long time to come up with these things in order to do this. Also, people think that architectural development is a one-time initiative. We start out, of course, with organizational needs that become instantiated and integrated into a data information architecture that then authorizes and articulates specific information system requirements. We need a feedback loop on there to show that we heard and can make improvements, and people think we're done. And of course, the answer is no. You need to continue doing this until the organization stops changing, and I've never seen an organization that's actually stood still in that context. One more little section here as we're running our way towards Brian's example of all of these things. I want to talk about data leverage, and the idea here is that understanding these engineering terms is very, very important. Just as we can move a mountain with a lever, if we have the right fulcrum, which also employs, notice, a people and process component in addition to technologies, data needs to have the same type of attention here. There is an engineering discipline that is not taught, and again, outside of Dataversity content here, it's very difficult to find in any part of the educational process that occurs. So again, helping organizations manage their sole non-depletable, non-degrading, durable strategic asset within the organization and across the data exchange partners, this leverage gives us the ability to implement people, process, and technology skill sets in a way. And there's something else we want to do in addition to that, and that's eliminate as much as the data rot as we possibly can. Now, data rot is data that is redundant, obsolete, or trivial, and you can see if we reduce the rot, the leverage effect will be larger. The greater the organization, the greater potential leverage exists, and this helps organizations lower IT costs and increase organizational knowledge productivity. This next slide is a little bit technical here. It just shows the domain, and the point of showing the domain being a constrained piece is that our data architecture component is the most stable component of anything in your IT and, in fact, business architecture. We can describe all of our data architecture components as either as is or to be, and either conceptual, logical, or physical. And our goal in all cases is to move them to a validated state. So for every change that we are doing in data architecture, every change can be mapped onto this framework. More importantly than that, though, we've done this a couple different ways. This is an even simpler version than I've shown in the past, which is to say that we do our IT wrong. We do it backwards. We have strategy and it makes sense to do IT projects, but what happens then is the data becomes the tail that wags the dog. The data is done after the IT projects are formed, after the software package is selected, after the approach is decided upon. And this makes sure that the data will be formed around the applications and not around the organization-wide requirements, that the process application is narrowly formed and very little data reuse is possible. Our ideal process is, in fact, to go to data-centric, which is to start out with our organizational strategy and then develop our data layer at that point. Once we have our data layer, then and only then should we specify IT projects, because this gives us the ability to make sure our data is developed from an organization-wide perspective, that systems supporting these data needs complement the organizational flows, and we can finally maximize the reuse of the one component that we should have an attempt to maximize. Again, just a side note, but the amount of software that we are reusing is as close to zero as it possibly can be. So architecting and engineering are symbiotic terms. They build on each other, and I've already given you an architecture example. Let's look at an engineering example. I ask people to say, what is this? Well, first of all, it has 4 attributes. It's taller than I am. It has a clutch. It was built in 1942, and it's still used regularly today on the USS Midway, which is sitting in the San Diego Harbor as a living museum. Now, what was going on when it was engineered, we were losing World War II. And by losing World War II, it was problematic in the sense that we didn't know how long it was going to take to do this, but we had roughly 1,000 soldiers that were on the Midway who were out there fighting the war for us, and one thing they needed every morning was breakfast. And it didn't matter how many of these wonderful KitchenAid devices that you brought in, the duty cycle for them would not have fed 1,000 people one morning before the motors would burn out, because they were not engineered to provide the level of service that we need to do. The only way we can do this is through standards, and we've talked a little bit about them. We won't dive into them here, but you can see it would be very difficult to make standards if every nail was of a different size, if every cinder block had individual characteristics. Similarly, as we're doing our architecture work, we also need to make sure that we have the focus not at the entire architecture, but on a specific work product. So it's important to look in and see what is going to solve your particular problem. I'll give you a couple of examples. Here's a hierarchical system decomposition that shows that the system is composed of 3 main processes, and that process 1 has 3 sub-processes. This level of documentation doesn't exist for many software packages, and yet it's something that we need to be able to articulate. Here is a decomposition of a series of model views from a government pay and personnel scenario. You can see level 1 is pay and personnel, level 2 has employment, administration, payroll, development, training, health and safety, and level 3 has the next level of decomposition there. The point is, when you're trying to look at some component of doing a project, not all of these things are going to be necessary. They're not all going to be necessary for your diagnostic work. They're not all going to be re-engineered at the same point in time. One last example on this, in a healthcare context, again, this is just looking at a 10-component decomposition. My point here is that if you have this level of understanding of the system, you can now circle in and say, we're going to look at just the things in clinical dietetics. That's number 7 up there, if that's what the area of your problem is. And it means you don't have to deal with all the rest of the things that are going on in there. These architectural components represent the most useful way of approaching a data architecture. Now, I've already mentioned data model views. Maybe I should expand upon that just a touch here. This is a state Department of Social Services, and it had some views: taxpayers, clients, governance, program delivery, and vendor views. And when you look at each of these views, you can see what are the things that are of concern to the taxpayers: payments, taxpayers, taxpayer benefits, social service programs. We can look at the client view and look at payments, clients, client benefits, local welfare agencies. The point is, we're simplifying this only because we have the entire architecture, and once I have the entire architecture, I can come back and break it down into some smaller bits and pieces. The governance view, as you might imagine, is more complex. We had governmental resources, governance, governments, payments, social service programs, the State Board of Social Services, and of course there was a thing called policy approval there that we needed to make sure that we pulled into play. Notice as I'm doing this too, a lot of these entities, architecture components, show up in the various views in multiple views. There's another one here, sort of a program delivery view. There are social service programs that are delivered to clients and service delivery partners and local welfare agencies. And I'll point out one other thing here too. If we were delivering these programs statewide, look at how the model would change. And this is actually one of the things that we talked about with this group of leaders in here, where they were looking at how possibly to simplify the overall environment. Finally, one last view on this particular piece here of this enterprise architecture from a data perspective. The vendors, and as you might see, the vendors, they have a lot of different things. They're concerned with clients, deliveries, goods and services, and of course the thing one vendor likes, payments, right? So again, here's the overall model for this particular organization. And I've just taken and showed you a couple of different slices of how that is useful. Once we have this information, we can now start to understand better and make more intelligent decisions about how we should do things, and the actual conversation about whether or not we should provide one set of benefits for everybody in the state or whether they should continue to be administered at the local level in each case was a very, very constructive discussion. Again, without this level of understanding, it becomes abstract and hand-waving and not useful at all in that context. So we're headed towards the next section here, and my colleague Brian is going to jump on the line here and show us a little bit about how he used one of these these concepts in one of the organizations that he's worked with recently on this. So we're going to move on from leveraging here to something called an NGO data architecture case study, and I'll introduce everybody to Brian Hogan making his debut here.
Thank you, Peter, and thank you for your earlier. So what we're going to do is we're going to talk about what an NGO is. So an NGO is a non-governmental organization. Essentially, that means they are not part of the government and they're not part of commercial. They're a nonprofit. And this organization that we went into, they are a global health nonprofit developed to help leaders, health managers, and communities in developing nations build stronger health systems. You know, they aim to improve the quality, availability, and affordability of health services. They work in areas such as HIV and AIDS, tuberculosis, malaria. But really what they do is they provide project management designed for healthcare implementations. You could say they're the general contractor. Because they're a project-based organization, it's important to note that they operate in many countries, and each country really runs its own projects, while corporate, which is located in the U.S., they provide the supporting services, you know, HR, IT, accounting. And so let's look at the problem they were having. Peter, if you go to the next slide, thank you. So really the data needed to make key business decisions was not accessible across the enterprise. The most leading challenges surfaced from being unable to obtain critical data from projects in a consistent and shareable manner. Some factors that contribute to this lack of access include timeliness. The time it takes from data to be created then shared can vary hours, days, or weeks. This is very problematic because decisions need to be made in a timely manner. An example of this is a project was running over budget and a few weeks behind, and they couldn't figure out why. Well, a few weeks later when the financials came in, they discovered that the cause of this was actually a company in charge of driving the trucks around were billing more hours than normal. So a fraud was happening. And if they had this earlier, they could have easily made that decision. Accuracy, you know, the data they receive isn't always trustworthy because it comes from many sources. Another example of this would be the monthly report that actually compiles the health of a project is actually compiled through email conversations and then put into an Excel spreadsheet. And we all know how that goes when you have to transcribe something from an email to an Excel spreadsheet. And the last one is data isolation. So data isolation means the data captured is siloed across many stores, and the data is not shared across the business units. For example, finance stays in finance, HR stays in HR. Each individual business unit thinks of data as a consumer, and they really fail to realize that they're also a provider of data to the other business units. So now that we know the problem, let's look at the root cause of this. And there's a lot of issues to why this problem was happening, but we're going to focus really on the ones around data architecture. First, there's no enterprise understanding of its data assets. They lacked a conceptual data model. They can even identify the data assets they have. Next, they don't have a common vocabulary, and the best example of this is the word project, which is extremely critical to the organization, means many things to many people. To HR, a project could be a set of work inside a certain country. It could be a set of work inside of multiple countries. It could be a IT project, and they actually had no definition for the word project. So when they were trying to report on the number of projects they had, it varied across who you asked. And last, they didn't have a system or data architecture. They lacked a vision. There was no alignment to any business model they had. And really, they had something called shiny object syndrome. Now, what is shiny object syndrome? Essentially, you focus on a tool without focusing on the root issue. And lastly, they had minimal integration because they really just picked tools out of nowhere. What they did was they would go to try to integrate something, tool A to tool B, and realize that nothing was compatible.
But Brian, I'm going to stop and ask you a question on that real quick.
Yeah, go ahead.
When you talk about project, that's one of those really excellent examples that most management doesn't really understand, because after all, we are familiar with PMI and they can define a project, but this organization literally used multiple definitions for the same word. And it wasn't just that, you know, somebody would say project and somebody else wouldn't understand that, but you said that it goes back into the counting the number of projects. So for example, if an auditor is looking at a country and saying how many projects are running in that country, and you don't have a definition of what project means for that country, you're going to get multiple different answers, which means the auditors ask more questions, scare people, right? And as you said, there was some fraud that was occurring in one of those instances that wasn't necessarily related to project, but that's a great place to come back in and explain to management and say, look, unless we all use the same definition of project, we have some big challenges, and this caused lots and lots of turmoil within the organization. I think you did a real interesting job of describing that.
Yeah, that was one thing that I know when we first came in, we're like, all right, you know, trying to get some background on the organization. How many projects are you guys doing right now? We asked one person, it was X number. We asked another person, it was Y number. We're like, wait a minute, what is your definition of project? And that's kind of how we got to say, wait, you have no definition of project. That's critical.
It absolutely was for these guys. This could be different for every organization, but certainly for these guys, this was definitely one of the important pieces.
So now that we've kind of discussed problem and root cause at a brief statement, how do we come in and help? Well, first we began down the path of creating a couple of things. The most important, a vision and purpose, you know, the foundation for data architecture. I know Peter kind of talked about, you know, the definition of data architecture earlier, but really, you know, to us in this context, it represented the vision and concepts and principles for developing and managing an organization's assets and support of strategy. The next thing we created for them was a business glossary, and that was important so we could at least define the terms that are important to the business. And lastly, what we did was created a conceptual data model to show how it integrated through the organization and how it also flowed through the organization. So if we want to go and look at the vision and purpose in a little more detail, so this picture on the left is really your 100,000-foot view. It describes, you know, the processes and procedures and technologies that make up the components. And we're looking at this picture, it's in a very conceptual view. And I understand now, I just saw that the box on the right is actually data governance. I'm sorry about that image got turned around.
Oh, we did forget to catch that, didn't we? Yeah. Hey, data governance never gets confused, right?
Yeah. But really, you know, in simple terms, I'll break down this picture really quick. The black arrows indicate a flow of information, which adhere to a certain set of messaging standards. Gray boxes are investments to help support the purple boxes, and the purple boxes are where we actually deliver business value to the organization. And the top part, the green, is kind of where the data originates. So talking about the target vision, let's talk about how we came up with the target vision. You know, the majority of the data needed to support operations originate within projects, and much of the project activities obviously occur in different countries. To us, this type of operating model is sometimes referred to as a federated business model, and that aligns with the current direction of the organization. A federated business model can be explained as a set of distributed business units which operate with autonomy to accomplish their goals, while a unifying entity provides a framework and oversight to support the various business units. We determined that capabilities need to be implemented in order to capture the important project data in a time-sensitive fashion. So because we knew the organizational strategy and where they were going, we determined that, you know, the targeted vision needed to have a federated data architecture. And I know that's not really a widely term, it's kind of a term we made up, but it makes sense to us. So what a federated data architecture can be explained as a set of entities or projects to have a level of autonomy to support its goal, while a unifying entity, shared services from corporate, provide a framework and definition on how data is being managed and captured. And what's critical and what makes a federated data architecture work is the concept of messaging, or how we transfer critical data, which we will cover more in a couple of seconds. Once critical data is defined, standards and formats should be established to show how the data should be made available. Now let's go over some characteristics of a federated data architecture. Like we stated before, the target state vision represents a federated data architecture with respect to data flow, which is a structure that allows for autonomy at the lowest level of operations. The major concept that ties a federated data architecture together and allows autonomous units to share data is enforcement of an information exchange standard, or what I refer to as messaging. Essentially, as long as the data strictly adheres to a specific messaging structure, it can be consumed and understood outside of its origination point. As an example, consider a set of financial data detailing a specific transaction from a vendor. Regardless of how data was created, a spreadsheet, application, the back of a napkin, if the data ends up in a properly defined format, it can then be sent and stored in a defined spreadsheet or structured database. The next consumer of the data doesn't care how it originated and can consume the information needed to make decisions. And by sharing this messaging is valid, it adheres to the standards and integration of the data. So that's kind of how we set up their vision and purpose. And then next what we worked on is actually the business glossary. So to them, they didn't have one, so we said, let's start one. It's the start of enterprise-wide taxonomy. Then by doing this, we were able to define critical business terms, and that's important to us because that actually helped us define the initial entities for a conceptual data model. It also ensured that the terms used in the model could be understood and read by the business community, which is important because when you engage the business community, you establish trust with them, and you can also begin to understand the business needs that they have. Last, let's look at the conceptual data model. So and Peter, I'm going to refer back to your other slide earlier when you showed different views. Really, that's what this is here. So each box is a financial management view, a business development view, a project management view, and a talent management view. But to get to this, we had to start with all of the terms we defined in the business glossary. And because we have this now, we can determine all the linkages across each business function. The next thing we show is this helps us show how the data flows throughout the enterprise and how it can be understood and consumed from users. Any changes we make, we can now understand because we can see the impact that we have. Like I said before, we define a common vocabulary, so someone in HR can pick this up and understand, okay, this is what I need. This is the data I need to help do my job. And that also helps us align to support the organizational strategy.
So when you're looking at this diagram here, it's just a different way of looking at the same information I was looking at the social services program.
Right.
And one of the things that you need to have is this ability to represent this in the right form for the right users. This is much more detailed than the one that I showed, but for the purpose of illustrating to people how data flowed across the enterprise, this was absolutely key, whereas my set of diagrams there before showed a different problem. And of course, that really is what it comes down to. What problem are you trying to solve? If we don't have that problem understood, all the diagramming techniques in the world, all the drawings, nothing was going to help you on that.
Awesome. And then what's the best part about this is what business value did they get out of this? And really the immediate one is we introduced a vision of how data should be managed. They never had this before, so it helped them identify the enterprise functions they must improve to move their organization into a better data management capacity. Also, it helped with creating a cadence to review and refine the existing architecture they had. And a couple other things, they supported organizational strategy, reduced IT costs, there was some data asset knowledge and reuse now, and also enabled accurate and timely reporting. So let's talk about some of the organizational strategy, why that was important. First, it was important because we had the vocabulary defined by the business community, and that increased the cohesion between business and IT. It allowed the business to understand what we were trying to accomplish, as well as help IT start understand the business needs. And cohesion between business and IT, it increases the chance for everyone to support business strategy, and I see you move along. You can give next to Peter, it's okay. Reduce IT costs. You know, there's the vision we put in, it helped guide IT on software implementation, which is hugely important because it mitigates poor software purchases. They, instead of buying and creating software that, you know, goes against what they had, they can look at their blueprint and say, hey, you know, this fits in, and that overall reduces the cost of implementations. Next, it allows IT to maintain and manage the critical pieces of the data landscape. And Peter touched on ROT, and when you're trying to manage everything, you know, there's a huge cost associated around that. When you're just managing the critical elements, you spend less time, less money just managing those critical ones needed to make the architecture perform. The data asset knowledge and reuse, the first thing it does is it increases organizational learning, which is hugely important to this organization because they can better leverage the data assets for reporting and daily operations. You know, the users now know what's available, and that means less time searching for the information they need. There are key integration points. It allows IT to focus on the critical data assets and the reuse of data assets for future integrations. And that leads obviously to faster and cheaper integrations. Last is it allows us to identify the impact of data flows, ensuring that existing data assets do not get hindered by any future implementations that you have. And lastly, the biggest thing that they got out of this is that it helps them increase and get faster timely reporting. You know, the time to build reports goes from weeks to days because the data is ready for them instead of having to compile it through email reports. There's a single source of truth. They can go to one location to finally get the data they need, and there's less massaging of the data. They don't need to, you know, convert it from a number and an email to a currency in a spreadsheet. They have that for them, and because they're not compiling all that redundant data, there's a lot less errors. And that's really the business value that they got out of this more than anything in the world.
You can imagine being in the elevator speech scenario now where somebody says to you, so you built a data architecture, what did that do for us? The answer might be we were able to implement a healthcare solution in country X in 30 days, whereas the last time we tried to do something comparable to that, it took us 30 months. And so that's the kind of thing that management picks up on and pays attention to when they understand this. But thanks, Brian. Real nice little case study in there, being able to understand that. Let's do a couple quick takeaways, and then we'll move to the fun part, which is your questions and answers. So people ask the question, why would you architect data? And A number of good rhetorical questions have been provided. Would you build a house without an architectural sketch? The model is the sketch of the system that is to be built to support the particular business need that you have. Would you like to have an estimate of how much your new house is going to cost? If it's just words are describing it, that's one thing. But if you've got a picture of it, people understand you're using rock for that and a lot of glass and, you know, whatever it is that you're doing. The model gives you a good idea of how demanding the implementation work is going to be. If you had a set of contractors from all over the world to build your house, wouldn't you like to use the same language? The model gives them that common language that they have. Would you like to verify the proposals before you get started working on that? Yes, and they can be reviewed numerous times before and during the implementation. And as you mentioned, Brian, as well, when something changes, as inevitably it does, we now can look across the organization and see how far the propagation of those changes are going to be from a data perspective. If you're going to build a great house, would you like to do it again? Yes, we'd like to be able to go back and do it again. So this is where this documentation comes in critically. And if you're going to drill into a wall in the house, would you do it without understanding where the plumbing and the electric lines were? Again, safer for maintenance and support all the way around. So we're headed back to the top of the hour on this, and we'll just come up with a couple of conclusions on this. An information architecture is not well understood. Brian and I will talk a little bit at the top of the hour here about his own journey to get to where he's come from. But, you know, what is an information architecture? It's this structure of data-based information assets. So you've got to separate that concept, even though we use the same word, database. It's something we're working on in IT to try and support that. And people don't understand how databases support strategy, but they certainly will understand how data can support strategy. Look at Amazon, Google, Apple, all of these companies that are based on these types of projects. Most organizations, 90% of them that we work with, have data assets that are not supportive of strategies. That's a problem. Their information architectures are not helpful. It's not that they don't have an information architecture, it's that they don't understand their information architecture. So the question is, how can organizations more effectively employ these architectures to help them support the strategy in their organization? And the answer to that is by using these information architectures. They are the application of data assets towards the organizational strategic objectives. They can be objectively characterized by the maturity of the data management practices, back where we started off with the CMMI and the MBOK components that I showed you at the first couple slides. That doing this by understanding and managing your information architecture, it results in increased capabilities in the organization. It results in increased dexterity and self-awareness within the organization so that they're able to use it in this context. And it can be accomplished through the use of data-centric development practices. That's a topic that's upcoming in a future seminar on here where we'll talk about that in a little bit more detail. So the question then is, how does an organization better use its existing information architecture? And the answer is continuous redevelopment. The starting point is the beginning. The only time you start off with no information architecture is when you have no organization. These information architectural components must be re-engineered using a formal, iterative, incremental approach, focusing on some subset. I like to say one component at a time, and applying a series of formal transformations in order to get us to the new organizational design that we'd like to have. So let's jump in for our question and answer period on here. And Brian, I'm going to put your picture up here as well. And Brian, as we're getting ready for this, your background is actually of an application development person, right? You came to this data stuff through software.
I did. I actually, you know, I started in the software development phase actually over here, and then through different teaching and learning and seeing how data actually is so important, even to developers. I mean, I know taking a data-centric approach to development has saved, not myself, much time and money, but I'm sure it's saved different organizations that as well.
And I'm just drawing this out here for a little bit to illustrate a point. I never had you in classes, but I had your classmates who would tell me stories about you that were all good. You know, it was like, oh yeah, well, I always want to be on Brian's team because, no, it was, I always want to be on Brian's team because he really gets this stuff in applications. But we didn't teach you anything in your undergraduate program about this data stuff. And it's just appalling to me that we continue this practice of showing people that software is the only answer. And I think you're a really good example of understanding that your software background is now complemented by your understanding of the data components that you have in here.
Yeah, I agree. I mean, it really is a disservice that data is not more, I guess I'm trying to find the words, it's not better articulated into the curriculum of the universities, because it is super important just at a base layer to know that, I mean, the most you get out of university now is what is a database, and really that does no justice to the overall picture.
An important component, but not the only one. There we go. I've got you on that last slide
there
here now. Stephen, do we have some questions from our
Absolutely.
colleagues out there?
So we'll go ahead and move into the Q&A. So it's time for you guys to ask questions. Just click on the Q&A window feature there. You should see it on your screen. You can submit a question there. I'm also watching the Twitter feed, so again, you can tweet with the hashtag of DataEd. All right. So
or go ahead and yell at us about stuff. That's fun.
Right. Tweet, yell, you know, messenger, pigeon, whatever. You just
what was Shannon's word? Tweet?
Handle it. All right, so moving on to the first question here. Brian, how did the new taxonomy become visualized and socialized to a widely diverse developer audience? Intranet, tools, and this is referring to Brian's example, of course.
So the main way it became visualized and socialized was through their intranet, and you have to understand the complexity around that is because they're in many countries, that had to be translated in a few different languages. So the best way for them to do that was through their internal intranet.
Okay, and so here's the question.
Let me add a point to that, though, Stephen, because one of the things that we've discovered is that when you start giving people answers, they actually like that. So one of the things that becomes part of the conversation now is when somebody in the organization says project, everybody turns around and looks at them and says, are you using the standard definition for project?
Exactly.
That's right. Next question is, how do messages exchanged relate to the model?
Really what it is the model is the base understanding. And from there, the detail of the messaging and the messaging standards need to be developed, and that really requires business and IT working together. But in terms of, if we're talking about this one that Peter has on the screen, I know really the black arrows pointing down is where the messaging fits in. So at each point, that's a transformation. And I don't mean transformation. I mean it's a critical path to where it goes from a general work in progress document or a piece of data somewhere, and then it goes into the capture phase, and that is where the messaging goes in.
And how about here, Brian? Is it the same answer here, or is this a different representation of the same thing?
So it's a different representation. So this is the base understanding from what we create the messaging, of how we create the messaging. So we look at this right here, and we understand that at a high level that this is what we're trying to capture, and the next phase of this is going to, we've defined the common vocabulary, so now the next phase is to actually develop the messaging standards or the information exchange standards.
Great, thanks.
Okay, and the third question we have here is, in a federated data architecture, how are the messaging standards developed and enforced? I guess it's just a little more detailed question, follow on to the previous one.
Really, it's a people first, then process. So you need your business involvement to define the vocabulary. The next thing that happens after that is, you start with this business glossary to understand what you were trying to capture, and then more so after that, it becomes an IT function, and that is managed and governed through the data governance. And if we can look on the right side of the picture Peter has up right now, that is where you're really enforcing those messaging standards, is through that data governance aspect. But the creation of that, or the development of that, really begins in IT and understanding what you were trying to capture.
Okay, that is the end of the questions that I see. So if you guys have any more questions, please feel free to ask them. Having some fun conversations here with Christopher Bradley on Twitter. This is good stuff.
Hey, Chris.
Okay, checking the chat. Oh, okay.
Well, you know,
more questions.
And,
sorry.
I was going to say, speaking of Chris and data, my AI tells me that it's Chris's birthday tomorrow.
Ooh.
Wow.
Happy birthday, Mr.
Happy
Bradley.
birthday.
Well, finally make it to 50, right?
Okay, so we've got a question here. My IT team wants to implement a NoSQL data warehouse by combining common columns in several siloed systems. Oh, that sounds like a Dr. Seuss book. Several siloed systems, as opposed to starting with data architecture. There's no dictionaries for the existing systems. What do you think of this approach? Peter, you want to take that one?
I think Brian could hit it out of the park as well, sure. I mean, you could technically do exactly what is being described, but the question is, what business problem is being attempted to be solved, and will those columns, in fact, actually produce the right results? There are a lot of people who think that, in the same way that if you had asked this NGO before Brian got involved with them, did they need a standard definition of project? The executives would have looked at you and gone, no, that's what we do is projects. But it turned out until Brian was able to go in and show them how multiple definitions of projects was in fact not supporting their strategy, in fact actually hurting their ability to deliver the mission, there was no chance that you would have ever gotten beyond that initial conversation. We tend to work in rules of three, and if you've had a chance to hear our CEO, Louis Broom, talk on this subject at all, the first version of the warehouse is typically the one that's being described. Sure, we'll grab some stuff, put it together, and it'll be wonderful, right? Then the second time they come through, they get some advice, and they try to build it. It isn't until the third time that they actually kind of get what it is that Brian and I are articulating here and saying, before you go through and build anything technically, you really should understand a very good definition of what business problem is being attempted to solve and whether those columns will do it. Because if you're using the wrong definition of project in those columns, you will have a problem. I'll tell you a very specific story about that. It's related to it. Our business school that Brian and I are associated with almost came out with a huge publicity campaign because we had been put into the top 25 business school categories. That's one of those things where everybody would love to be in the top 25. We actually measure ourselves around 100 best business school out there. But 25th would have been a very significant accomplishment. And luckily, the person who was in charge of that went back and looked at the data sources that were there and found, just as Brian was describing, they had been using multiple definitions of projects. Somebody had been also similarly defining a term incorrectly. And we were able to catch that out without having to go out and say, oops, sorry, I know we told you yesterday we were one of the top 25 business schools, but we no longer are. We kept our mouth shut, which was the wiser thing to do all the way around. And Brian, you never heard a word about it, did you?
No, I did not.
Yep, so that's one of those behind-the-scenes things. So, Brian, you want to offer any guidance to the questioner there?
I think you summed it up perfectly.
Okay.
In that case, aren't any more questions? All right, we're getting
we got one more here. How granular do you go to define the business glossary? The example looked like it was only entity level.
So really, how granular you go is important. So right here we see that this is only entity level, and that is the starting point. So when it comes down to more discrete level, if you want an application to talk to another application, you're going to have to go pretty granular. But in terms of what we were doing just for this, it is definitely at a higher entity level.
Let me tell a little story about business glossaries here. And in fact, Karen Akers, who's up in DC doing one of these events right now today, and I are going to give a presentation on this at the Data Governance Conference coming up in June. Wait a minute, I'll go back there, put that slide up. There we go. Nokia, a company I worked with on and off for a number of years, very, very fine company, had built into their culture something that they called the Nokia term bank. And this construct that they used was something that was built into the culture. So I can remember many, many meetings where I would be at working with the folks at Nokia, and somebody would use a term. It might be me, it might be somebody else, it might be my funny American accent to them. But they would say, wait, I don't understand, what is this term that you're using? And when I would define a term, or they would define the term to each other, one of the first questions that was asked of this company was, is that term in the term bank? And they would immediately pull up the nearest computer, get on their website where they had the diagram, Brian, that you showed at a more detailed level in an interactive living document. And they would go straight to that document and say, is this term in the term bank? And if not, there was a form at the bottom where they could click, and it would be added to the term bank, or it would be put in the governance process where they would decide whether that term should be in the term bank and what definition that it should have in the term bank. Let me give another example. So Nokia had built it into the culture, and it was a very, very effective usage of the concept that Brian outlined. I was working with a major health system recently, and they had gone through an exercise where they discovered not one entity, but in fact one attribute. And the attribute was something that they called admit date. And they found when they did a census of how admit date was used organization-wide that 11 different usage of admit date were occurring across the organization. And the problem with that was that when we added up the business value of 11 different usages, we found out that we had an enormous amount of money that was being incorrectly spent, allocated, and in fact misallocated on this, amounting to over millions of dollars. It was just an amazing amount of money. And what we did in addition to this, we created the artifacts that Brian described as well for this organization, but we also told stories, and we made sure that every aspect of the organization understood that from January 1st of the year that we implemented this onwards, everybody would use a standard definition of admit date, and that by using anything other than the standard definition of admit date was a serious violation of organizational policy and cost people money. We never found an instance where it actually impacted health, but of course dollars impact health indirectly, so we would certainly get to that as well on that. Again, great question. Certainly appreciate your interactive dialogue here. Anything more, Stephen, on this one?
Yeah, I got just a couple others, and this one I'd be happy to answer. Peter, this is, what business school were you referring to?
So Brian and I are both affiliated with Virginia Commonwealth University in there. And,
not just you and Brian.
That's right. Got a couple of folks there.
Go Rams, go.
So,
that's right.
Yep.
All right, and I got one more here. How highly normalized should the conceptual data model be in order for a non-technical user to derive value?
Great question.
Peter, you want to take this one on?
The key to it is that if you start a conceptual data model, if we go to the strict definitions of it, is a logical data model that has no attributes, keys, or anything else. It is really dealing with concepts. So that while we're not going to have, for example, many-to-many entities in this type of a data model, it's too much to get them down to it. What we're really trying to do is just sort of put the guardrails up and give them a framework to work with. That said, however, it can be extremely useful to show an example of how additional normalization can help the organization to achieve its strategic objectives faster, better, and cheaper through the use of improved data architectural concepts. So in general, not very normalized, but it may be useful to have an example that everybody understands and can use in sort of an elevator speech-like mode, so that if they need to do it, they can do it. I'm looking here on the diagram, Brian, and trying to see if there's anything in here that we might call out as a specific example. I don't think you have any many-to-manys in this one.
Yeah, we tried to stay somewhat away from it. I'm trying to look in myself and...
By the way, never use the term normalization with the business users because they won't, right. And let's go back to college and universities. We've found examples where people are actually teaching this stuff wrong in college and university, so it's not an easy concept to grasp. Think about it for a minute. Normalization means we're going to reduce data redundancy by making more tables.
Yeah.
My head's going to explode, particularly as a 19-year-old undergraduate.
All right. Well, I don't see any other questions coming my way. Shannon,
Thanks,
have I missed
everybody.
any?
Thank you so much.
No, I haven't
Peter,
seen anything else.
All right. Well, thank you, everyone, for participating in today's event. We hope you enjoyed it. We certainly did. Thanks again to Dataversity and Shannon for hosting us. Once again, you will receive today's material within the next 2 business days. Our webinar next month will be Data Governance Strategies on April 12th. Hopefully you'll be able to join us for that one as well. As always, feel free to contact us if you have any questions. I hope everyone has an awesome day. Thanks again, Shannon.
Thank you, Stephen. Nice to have you back this month for joining us while Britt's out on vacation. And thanks, Peter. And welcome, Brian. Thanks for joining us for the first time. Very much appreciated. It was a great presentation from you both. And thanks to our attendees, as always, for participating in everything we do. You know, and just another special shout out to longtime Dataversity friend, Chris Bradley. Happy birthday. Who's actually in Saudi Arabia today, normally residing out of London. So it's already his birthday for him today. Hope everyone has a great day, and we will see you next month.
No, we'll see everybody at EDW. Come on. Big party coming
Well, we'll have a webinar first.
All right, webinar first on the big party. We'll see everybody.
Cheers.
Bye all.